Good afternoon, everyone. Welcome to this week's episode of The M Word. My name is Robin. I'm the Technical Director of Man & Machine here in the UK, and as always, it's a pleasure to be talking to you this afternoon. Thanks for taking some time to join us on the channel. So, for those of you that are new to these sessions every Thursday, welcome. For those of you that are not new, welcome back. And the idea really behind these sessions is to share something with you in the wonderful world of Autodesk software, services and design that we live and breathe here at Man & Machine. So sometimes we do some construction-based workflows inside of Revit. Sometimes we do some manufacturing-based workflows inside of Inventor. It looks like for some reason I'm broadcasting a little bit fuzzy and out of focus. Hopefully it'll catch up in a minute. Hopefully you can see me and hear me clearly. If not, I'll try and fix that as we go through. But yeah, essentially we're here to share something with you with regards to a workflow or a piece of functionality, a tip, a trick, or a what's new inside one of the Autodesk tools. And over the past few weeks, we've been doing votes on our LinkedIn page to really give you a chance to vote for what you would like to see. Last week it was a tie between Revit phasing and design options and Inventor frame generator. So we decided last week to do a Revit episode, so we focused on the design and phasing options inside of Revit. So this week, rather than running the vote again, we're just going to do the frame generator workflow inside of Inventor Professional, which is really good. Hopefully it's something that's going to benefit a lot of you on the session. Some really powerful workflows with that design accelerator frame generator inside of Inventor. If you haven't already, give us a like, give us a subscribe, and check out the other stuff that's on our channel, because it's not just these sessions that we go live on every Thursday. We regularly post new content up onto our YouTube channel every week. Sometimes it's a short video, sometimes it's a much longer video that's either, again, a demonstration or a how to do this, or here's a new piece of functionality. So we're regularly up there with new content, and hopefully those things are really beneficial to you. Give us some feedback and let us know what else you would like to see. So without any further ado, before I start, I guess, waffling on with more things out of my bandolier, we're going to jump into Inventor and do some different bits and pieces. So let's just shrink myself down into the corner, and if I can find the button, share my screen. So as always, it doesn't really matter what version of Inventor you're on to follow along with this tutorial. Generally speaking, whilst there has been some changes over the years inside of Inventor, frame generator has fundamentally been the same for a number of years. We've had some niceties added over the recent releases, but generally the core principles of what I'm about to go through and explain and show you are generally the same. So I'm using 2023. So the first thing I'm going to do is go ahead and create a new assembly. So frame generator is a design accelerator inside of Inventor Professional, and essentially what that means is it's going to accelerate your design. I'm just looking over to make sure that I'm not too blurry. I think it's connection on the preview laptop that I've got more than anything else, so I think it's okay. Maybe someone can give us a comment with a thumbs up or thumbs down. But yeah, so it's a design accelerator, and we have a number of these inside of Inventor. In the assembly environment, if you go to the design tab, you can see that we've got a load of options from bolted connections, clevis pins, frame analysis, frame generator, tubing and piping, compression springs, shaft generators, and a whole plethora of other stuff. So we're going to be focusing on the frame gen today. And there's a couple of different workflows that you can use for this. So I'm going to show you, as always, the way that I do it. So whether that's right or wrong for you guys out there, it's the way I've always done it. And actually, I prefer the workflow to other ways of using frame generator. But generally, what we do is we start with a skeletal component or a skeletal sketch. And on that component geometry or on that sketch geometry, we tell Inventor to place standard sections and we extrude them on the length of those, and then we can tidy up the corners, so on and so forth. When I'm working with this, I always use a skeletal part. I just find it easier to work with a skeletal part rather than using a 3D sketch or a series of 2D sketches. So bear with me and hopefully you'll see why. But I'm going to start within an assembly. And before I do anything, I'm just going to save this away I'm going to just create a new folder in my documents just called FrameGen, and I'm just going to save this away called assembly1. So in here, the first thing I'm going to do is create a skeletal part. Now for the purpose of this, I'm going to use a standard metric part. Where are my metric things? They've disappeared, so I'm not going to use that. I'm going to go into application options and change my default templates, files, default templates. I thought I already changed this last week or the week before. Let's go into an ISO, overwrite and apply and OK. Okay, so we'll try that again. New assembly, make sure it's metric, otherwise that will really throw me. And then we're going to overwrite this one. Great. So from here, I'm going to create a new part. Okay, so that part, I'm just going to create a standard IPT, and I'm just going to call this skeleton. Okay, and we're then within the part creation environment. So all of your standard tools. Now, if you think about what it is that we're going to do, maybe I want to create a simple frame for a component to sit on. Maybe it's a bot in a factory, maybe it's the top of a table or something like that. And if you think about what you need to define that table, you're going to need some edges to be able to run your box sections up along the side, along the top, and along the other sides. Why would I do that with several sketches or one fiddly 3D sketch if I can just use a box? So I'm going to use a skeletal box to start the creation of my frame. So in here, I'm going to create a new sketch. I'm going to use the XZ plane here. Just to create the top-down view of this particular piece of framework. Let's place a 2-point center rectangle, and let's say that I want my frame to be not overly massive. Maybe we'll go 500 by 425 with regards to size. Something like that is absolutely fine. Let's go ahead and finish the sketch and extrude, and I want this to be about 750 millimeters high. So I've got something that looks a little bit like that, maybe a little bit less. Maybe we'll go with 540. Great. So what I end up with is, yes, a simple box, but Frame Generator works off geometrical components. So it works off things like points and edges and faces. So if you can see what I've got here, I've got an edge, an edge, an edge, all the way around the different components and the different axes. Any one of these pieces of geometry I can use to define a frame. Therefore, I've already got the basis of a very simple table, if you like, or simple piece of framework for a bot in a welding factory or something like that. I'm just going to add a final little piece of geometry, perhaps to one of the sides here. So I'm going to add an additional sketch on the side of this face, and I'm going to go with my line tool. Let's project the geometry here. And let's go with a line tool that's going center of this to the center of this. Finish, sketch. The final thing I'm going to do is just make this a different material. So because this is a skeletal part, it's a bit of a mouthful, because this is a skeletal part, what we're going to do is turn it into a more transparent material so it's not that visible inside of my system. So I'm going to come in and just say, change the material of this to glass, for example, just so it's slightly transparent. From there, I'm going to put on another save just to keep this nice and fresh. And then I'm going to go into return to go back to my top level assembly. Once again, I can save in there as well. From here, I'm going to go to the Design tab and open up the Insert Frame command. That starts Frame Generator and tells Inventor that I want to place a frame. Now, this will open a floating window, but as of, 2 years ago, maybe 3, I can't remember the exact date, Inventor now has these lovely dockable windows now rather than the old floating commands that we had before. So we can dock this, we can put it on a separate screen, I can dock it as part of my main browser. Do with it what you see fit. I'm going to have mine on the left hand side, that's where I like it, but move that wherever you like to. Okay, and if you want to drag it out and move it onto a different screen, you can. I'm going to dock it over here. And you can see within this window that we've got a whole different range of different options. So from the top, I've got presets. So everything that I do within inside a frame generator, I can save. So I can save defaults, I can configure my favorite templates and reuse them time and time again. I'm using a completely off-the-shelf install of Inventor today, hence it's installed in Imperial rather than Metric. So yeah, this is completely off the shelf, but I can come in and choose presets if I've got them. I can pick with the pipette here to go and grab a frame that I've already added into the model and reuse it. And I can also change the settings for those presets as well. So what I need to do is start selecting some geometry. We can select with the single point, so we can click any piece of geometry, whether it's a sketch geometry or a piece of geometry from a 3D component, which is what we're going to use here. We can do it individually, we can window select, we can tell it to ignore center lines on a sketch, ignore construction lines on a sketch, all the stuff that you would expect. All I'm going to do is I'm going to go around and just start showing you that as I hover over geometry, whether it's sketch geometry, whether it's 3D geometry, it's starting to give me a preview and it highlights the component line, okay? So let's go ahead and select this edge. What that does is it gives you the preview of this simple piece of box section centered along that edge. Now I can start controlling what it is that I'm placing. So currently I'm looking at all frame members on the ANSI standard, and then I'm looking at a specific family and size. I can come in here and say that I just want to look at basic box section. I want to look at the ISO standard, so it's a metric size, and I'm going to look at a ISO 10799, which is a square section. I can then choose the size that I want to use. Let's go 30 by 30, 3 millimeters thick, and I can assign a material to that, in my case a mild steel. Now this is being driven from Inventor's Content Center. Any of you that have used Inventor are probably quite familiar with placing nuts, bolts and washers using things like Content Center. This is using that Content Center to drive these frames. So what you have in Content Center is a profile, in other words this 30 by 30 by 3 mil thick profile, and it's just going to extrude that over the length of the geometry that you have selected. So I'm going to start with a single point selection just to show you what it's doing. So I define my component, I can start rotating should I want to, I can offset should I want to, and I can choose to align if I want to. I get this little gizmo which is relatively new, you didn't used to get this up here, but we can come in and start choosing how we want to align this particular component with regards to the geometry that we've got. I'm going to select the outermost edge here so that it's within inside my frame that I've drawn on my dummy. I'm quite happy with that, so I'm just going to press OK. Ordinarily you would add the rest of your frame, but for the purpose of this tutorial today I want to talk through it slowly. So I'm just going to place one of them. I'm going to visually hide my skeleton and basically show you that what I end up with is, where's my inspect tools measure, what I end up with is a frame using that 30 by 30 by 3 piece of box section that is 540 millimeters high. Why? Well, because the box, the edge of the geometry from the box that I drew originally was 540 high. So what Inventor has done, if I open this frame component on its own, is it's created this component. This component is essentially a section which has been extruded over a generated length. So all of these components have properties such as GL, and GL will be your generated length for that part. Tube and pipe works very similarly inside of Inventor, where you get a pipe length, and these GLs, generated length, can be used to get cut lengths and cut lists within inside of your bombs in your assembly should you want them. So all I've done is, let's be honest, a glorified extrusion, but using a standard section. Yes, the sections can be customized, and yes, you can use your own custom content center to create them. Let's go ahead and add some more. So let's turn our skeletal part back on. Let's go into my frame generator, and let's say that I want to add more frames. So let's say insert frame, and let's go ahead and add some more. You'll notice it's remembered my last selection, and I can come in and start making selections. So I can go, okay, let's go and select my other feet. And I can come in and select these as I place them. Inventor will allow me to change the configuration for all of them as we go through. Okay, so whether or not you want to place them all individually, align them all individually, that's completely up to you. I'm going to place these 4 feet individually because I want them quite specifically aligned to the components that I have here. And I'm going to press the little green plus for every one that I add, which allows me to very quickly go in and add a new one and align it to the correct positioning for that particular foot. So very quickly I can place these 4 legs like so. From there I'm going to insert a frame around the top edges, and along the top edges we can choose again to have a specific alignment for those individual frames. I can choose the top corner for all 4 of those, and you can see that that has aligned it really nicely to the top of my frame. I'm going to press OK, let it go away and save the frame. Let's hide my skeleton part and show you that we have the starts of a nice frame being added here. So we've got our component feet here, and we've got the top of our base, so to speak, at the top. Really straightforward, nothing complicated, but very easy. The names for the frame are given a generated name. That's all customizable using the tools that you have readily available in Inventor or Vault, should you be using Vault. There's a load of blogs out there on the internet that explain how to get these names customized. I won't go into that today. But essentially we now have this frame, and each frame member is its own generated component inside of this frame. Once you've got the base components, we can edit them, because at the moment these are just going to the extents of the geometry that I selected. Okay, so we've got lots of overlapping and essentially lots of mess on these frames. But that's where the benefit of this frame generator functionality comes in, because we've got a load of modification options at the top where we can really go to the nth degree in customizing and controlling how this frame reacts and works. In other words, I would like to have my feet stopping underneath this top section here. So what I can do is just spin this round and look at it from the underneath, and I can look at the top and say, oh, maybe for this we'll use trim and extend. I can choose trim and extend, and then I can select which frame I would like to trim and by which tool, if you like. So if I select the underside of this face and then this frame, it will trim the frame to that particular tool. And we can basically go around and keep doing the same thing. We can press the green plus to apply that, keep the dialog box open, and essentially trim all of these frame members down so that they are meeting up to the underside of the frame. So all of these feet now stop at the point that they reach the bottom of that frame. On the top here, we could either use the same thing, or maybe we want to miter them. Maybe I would normally say that I want them extended and trimmed, but to show you the additional functionality, I'm going to use miter. So I'm going to miter this component and this component. We can control how they're mitered and any offset that we want in there. I'm going to leave this all default and press apply. This one to this one, apply. This one to this one, apply. And the final corner over here, okay. What we end up with is 4 neatly trimmed legs and a neatly mitered top frame. They'd be ready for welding, they'd be ready for brackets and nuts and bolts, or however it is that you want to start generating them together. The fact of the matter is, I've created these 8 components very quickly, and all I've done is drawn a box, extruded it, and selected those 8 individual references. If I wasn't talking through it slowly, it's a minute's work, and we've got something that's already representing the frame. What about other stuff? So I've just used geometry for that component for these frames so far, but we can also use the sketch geometry as well. So if I bring this back, we've got this little line here, so I can insert a frame again. I could select this line, and then I can choose either to have the same type of frame, or I could choose a different type of frame. Maybe I wanted to have a slightly smaller frame for this upright, so I can come in and choose a 20 by 20 by 2 component and press OK. We'll just align that center so that it's, no, sorry, not center, edge center, so that it looks something like that. And then we can press OK. Once again, let's right click and hide the visibility on our skeleton. Now remember, in reality, whilst I'm hiding my skeleton, we wouldn't want that affecting our bill of materials in an actual design. So you might go in and change that so that it's just a phantom component, or it's ignored in a BOM, or you just suppress it when you don't need it, and therefore it's taken out of everything anyway. So bear in mind that with it just turned off, as mine is, it will be affecting the mass and it will be affecting the BOM. So just control that as you would any other component that you don't want to be taken into your manufacturing workflows. So with this one, we can go in and do some more. I'm just going to say that I want to use trim extend again. I'm going to trim this one to here, apply, and using this tool, trim this frame, okay. Now alongside those, we can also do corner joints, we can do lengthen and shorten, we can do notches, all sorts of bits and pieces we can do in there. If I want to change one of these individual components, I just click change, click on the component in question, and then I can go in and change any aspect of that component that I may want to, such as I want to come in and give it an offset. Oops, I can drag. Helps if I don't click the wrong button. I can change, select this, and I could start dragging or changing the offset as I see fit to be able to control how I want that particular component to appear in my design. So if I wanted to eyeball it so it was, did it again. If I wanted to eyeball it so it was in the middle, I could drag that across or use the type in values on the left hand side. Okay, so we can change these on the fly, and that includes changing the sizes of the members that it uses as well. So it's pretty quick and pretty easy. I'm going to come in and say insert an end cap. I can select the faces that I want to insert an end cap on. I can choose the thickness of the end cap. I can choose the offset of the profile. I can choose to make them much bigger. I can choose to make them much smaller. We can come in and really go to town with how we want that to be. Okay, so control that as you see fit. Zero. And make these, as big or as small as you want them. So I'm going to put in there a -5, no, not 56, a -5 size for those end caps, and then maybe they're going to be acted as feet. Maybe I'm going to have them up as 8mm, and I'd weld them on there, or something like that. I can add all of them at once and place them on like so. So without any difficulty really, I've come in and I've created this frame. Nice and easy, and it works really well. If I hit save, say yes to all and hit OK, what I actually end up with, if I just go and show you in File Explorer here, FrameGen, is my assembly, my skeleton, and then a folder that has a frame generator output. The frame is in its own assembly, and then we've got all of the standard components that have been extruded along to make that particular frame. Okay, I'm not going to go into how we start generating cutting lists in this particular video today because we're a bit pushed for time. But again, just use that G_L parameter, that generated length. You'd go in and make sure that it's being published to the part. You'd change your bill of materials and your parts list on your drawing so that it includes that, get it to sum them all up, and then all of a sudden, for all of your 30 by 30 by 3s, you'll get your cut length for your manufacturing. So lots of different options there. What I will do, however, is just start showing you some of the huge benefits of using this frame. So one thing that instantly springs to mind is your frame analysis. So let's just turn my skeleton back on and then actually suppress it so that it's no longer inside of my design. And then with this frame, what I'm going to do is I'm going to say that I want to go into the frame analysis environment. Now Inventor's got a pretty good FEA environment. It's both got the out-of-the-box Inventor simulation, and with the Product Design Manufacturing Collection, you've got Nastran in there as well for really high-end simulation that will do both linear and non-linear analysis to get material elasticity and stuff like that correct, or more accurate, should I say. Inside of Just Inventor Pro, we have frame analysis, and what that will do is it will work specifically with this frame. It will understand that these are likely going to be thin bodies. It will turn these into mid-surfaces and plane elements and edge elements and generate things like buckling and stuff like that. So just very quickly in the last couple of minutes here, if I go ahead and say create simulation, say OK, we're going to do a static simulation of this component. Okay, so with this we start getting all of those different nodes appearing. So each frame element here has a node point at the start and at the beginning, and we can go in and start seeing where this component is joining together. You have to specify your materials if you haven't already. We did that all in one shot. We said that we wanted them to be mild steel, so that's fine. But we can override them just like we can in the standard FEA. And then from here, we can create fixed constraints, pinned constraints, floating or custom constraints. We're just going to do a really simple version of this today, but maybe we'll do a more sophisticated one later down the line. We're just going to say that this is all fixed. So I'm going to fix all of my feet. So I'm going to say there, apply, fixed, there, and I'm just choosing that, that node there at the end. Fixed, there, and fixed, there. So that blue node, I've told it on every side that it's fixed. Okay? And then from that point, we can start defining where we want forces to be. So maybe on here, I've got a force along the top. So you can see that we're basically specifying where the force is on these edges. So I can come in and select the edge and put a force on there. And I can say that I want that force to be offset at 250, roughly halfway along the frame there. And then we press the tick and we have a force. If we come and look in our loads, we have a force here that we can then change the magnitude of. Okay, so we can specify where it is along the node and the magnitude of that force. Let's just put 250 newtons on here for the purpose of this, and we'll say OK. Let's have another force on this side. Maybe we're going to have 250 again. And again, we're going to change that force and make it maybe slightly bigger, 350 newtons on this side. So we can define forces to beams or nodes at the corner of the beams. We can add moments and continuous loads as well as actual movement and bending moments. We can start making connections between all the different components. So I can say that nodes are rigid linked together. So we can start selecting these nodes and saying that they're all linked and working with one another. I'm just going to be really lazy and just hit the simulate button. But you can go to town with this and put as much or as little information as you need, dependent on the reality of the results that you're looking at. So how realistic you might want those results to be. But essentially, with this very crude and quick analysis, what you can see is using these elements, we're starting to get a picture of what's going to happen with this frame. Much like standard FEA, this is all adjusted X amount of time. So this is 1 times adjusted. If I look at undeformed, actually our maximum displacement is 0.02 millimeters, so it ain't moving. But we can start getting an idea of how much it might be moving and where we might start to see where we've got problems of buckling. If we just look at editing these forces now, let's edit this force and let's place it on this frame instead. And let's not have, oops, let's put them back on. So let's place the force on this frame instead, for 100 newtons. And let's place another form on here as the same amount, 100 newtons. So if we put, oops, no, I didn't want to put that, 250, thank you. If you click and drag, it comes up with that. I should have just clicked once. So with those, we can see the difference between having this cross member here and not having a cross member. We simulate, let it do its thing. Again, very crude, I know, I'm not being overly realistic with this, but it starts giving me some expectation on how things are going to move. And you can see that the component here that hasn't got the cross member is moving ever so slightly differently to the one that does have the cross member. And if we start adjusting that, 5 times, we can see that there is, although very subtle, there is a difference between the components here. So once you start doing that report or putting these frames together, we can start using them to great benefit, whether it's the speed of which we can model a frame in the first place, or to what we can then do with those frames afterwards. So get your cutting lists out, put it as part of a frame analysis or a frame simulation to start getting some results. And either way, that's kind of what I wanted to show you today using Frame Generator. I hope that's been useful. In my mind, we don't see as many people as we'd like using these tools. The design accelerators in Inventor are hugely time saving for you. Hugely time saving, that doesn't make sense. They save a lot of time. They're hugely beneficial for you as a user. So whether it's bolted connection or frame gen or shaft generator, go and have a look at them, because there's a lot in there that can save you a lot of time and a lot of effort. We've spent half an hour today having a little play around with frame gen. I hope that's been useful and it's given you something to think about. And really, all that leaves me to say is thank you ever so much for watching. We need to put a vote up for our next session, which we'll do. We'll put that up on Monday or Tuesday next week. And I guess, what should we cover, or what could we cover? So anyone that's a geek like me probably saw the latest gameplay videos from the latest Unreal Engine. So maybe we'll have a look at potentially Twinmotion, which uses the Unreal Engine next week to be able to visualize from Revit. And remember, that's now included inside of your AEC collection. So option 1, Twinmotion. Something inside of Inventor. What could we do inside of Inventor? We could do another design accelerator. So why don't we look at, or we could extend what we've done here. That's what we'll do. We'll look at using your frame generator to create custom cutting lists. So cutting lists inside of Inventor. Another Revit one. What can we do inside of Revit? Let's see. We did phasing. We've done design options. Maybe we'll have a look at revision management on your sheets inside of Revit. That might be quite a good one. And one more for luck. Maybe we'll choose something a little bit different. Maybe a Vault one. Data standard customization inside of Autodesk Vault. Please don't choose that one. But we'll do those 4 as a vote next week. So check it out on LinkedIn and give us a vote. And don't forget to give us a like, give us a subscribe. Thank you very much for watching. Let us know what else you want to see. We do these sessions every week, for a bit of fun. It's a chance to speak to you all outside of our customer base. So check us out on the web, check us out on LinkedIn. And yeah, until next time, have a great week and we'll see you soon. Take care. Thank you. Goodbye.